All right, Josh, take it away.
Okay, so I am Joshua Bromley here. I'll be presenting on the Breakthrough Listen project and my work with the project. So, as you know, I graduated from IW Wells, formerly Wilson High School, class of 2020. And I'm now a physics major at UC Berkeley, and I intern at the Berkeley SETI Research Center. So the Berkeley SETI Research Center, which hosts the Breakthrough Listen project, but they're kind of the same. That's kind of the only thing the SETI Research Center is working on right now. And our goal, I guess, in general, is to find aliens or find intelligent life somewhere else in the universe. And the way we do that is, instead of looking for evidence of life itself, is we look for evidence of technology called technosignatures. And the two main technosignatures we're looking for are anomalous radio signals and also evidence of megastructures. And megastructures would be any large non-natural object in like space, so moon or planet sized or larger. And so the Breakthrough Listen project mainly works with radio astronomy, but there's some visual. So the instruments the project mainly uses, this is the Green Bank Telescope in West Virginia. It's a massive radio telescope. This is the Parkes Radio Telescope in Australia. And this is the automated planet finder at the Lick Observatory. And so these radio telescopes are massive. I think this one is 100 meters, which means the dish is about the same size as the track at Wilson, compared to like the little 4 and 12 inch optical telescopes that Mr. Minato has in the library. And so using these instruments, the way we look for technosignatures is we'd point it at a target, and then we'd observe the target, and then we'd observe somewhere else in space, and we do that over and over again, because we need to make sure that the anomalous signals we pick up, not only, so we need to make sure that they're actually coming from space and they're not either interference from the ground, like someone leaving their Wi-Fi on. So that's why we point it away from the target, and also that they're not interference from the sky, either satellites or aircraft, which is why we do multiple observations. Now, my group is called the TESS XRP group, and we are looking specifically for anomalous light curves. So that's like the light coming from a star has some weird behavior, and we're using the TESS data set, which I will talk about a little later. And so the lead researcher who basically has this machine learning algorithm that we can put many, many stars or light curves through to identify stars for further investigation. So these are two light curves that have come out of that his algorithm has identified as anomalous. And then from further identification, we have determined that it's from natural causes. So this top one is an eclipsing binary, and this bottom one is a Cepheid variable. So these aren't evidence of technology that were completely natural, but it's just narrowing down like all of the stars to just a select few that we can investigate further. So now TESS, or the Transiting Exoplanet Star Survey, is where we get our data from. And so that is a space telescope that NASA launched in 2018. It's a successor to the Kepler Space Telescope. It deals in visual observations. So we are getting so stuff you would observe from a telescope. That's the wavelengths of light we're dealing with. As you can see from this sky coverage map, anywhere that is not gray is going to be observed by the TESS satellite for at least about a month, 27 days, with greater concentrations around this the area where James Webb is going to observe. So we have a month-long light curve for almost all of the sky. And so the goal of the TESS data was to identify many exoplanets, which it has already. And then we're taking kind of this data that we have from it and then running this, looking for any anomalous stuff in the data. So we're kind of a secondary analysis over its main goal. And so how I mentioned about, this is a slight digression about the motivation of what we're doing. And so the Kepler telescope, which is kind of the predecessor to the TESS telescope, was launched in 2009 and ran until mid 2010s, I think. Can't quite remember. And it observed a small patch about a quarter of a percent of the sky, which is about 2 Big Dipper bowls. So it's not too much of the sky for exoplanets, and it found a lot. But one of the things is that this star, Boyajian star, which I have a light curve here, was discovered by citizen scientists in 2015. And so this was a star that was discovered only after people went through and looked through the Kepler data. And they found that it experienced these weird 20 and like 25% dips in brightness, which is really weird. And we don't know why it does this still. So we just have, but it shows that in this small patch of sky with all the data that we have, there is just like weird behavior going on. So the motivation for what we're doing is, instead of having people manually go through each of the light curves one by one to look for if anything weird is going on, we're trying to accelerate that process to use machine learning to go over millions or millions or hundreds of millions. I believe the total test data set is around 100 million light curves, if not more, to identify anything like this. And so we're getting to my job. So my job within my group is to work with signal injection and recovery. So in general, signal injection and recovery is a test, is basically you test an algorithm by making a fake signal. So something you want it to find and see if it finds it. And so my job would be to take a boring test light curve, something normal, something with very little variation, and then modify it to simulate what would happen if if that star had a megastructure transiting in front of it, and then insert that into the data set for the algorithm to find. So we're basically seeing, well, would our algorithm find a megastructure transit as being weird or different, especially if it's a different shape. And so these are boring test light curves. This one isn't normalized, so this is numbers. But as you can see, the variation on this is less than 1%, less than 0.5%. So it's like all this up and down is basically nothing. And I think it's similar for this one. And they're relatively flat, aside from data breaks in the way the TESS satellite operates. And then what I would do is generate a different light curve. So this one here is generated. There's this algorithm that says, well, if I had something shaped like this transiting my star, this long rectangle, which maybe could be someone built maybe a disk or just a long rectangle or a donut, and it transits a star, what would the light curve look like? And so you get transits that look like this, or you have some that look like this. So as you can see there, you can see the slight differences between the transits of the two different shapes. And if I had one of a planet, you could see that the transits all have slightly different shapes. And so you take these transits and you put them together. And so what you get is that you have now the transit here with the noise background of TESS. And so you take these like this, and then we'd put them back into the data set to see, well, is a light curve like this, would that be identified as weird? Or would a light curve like this be identified as weird, especially with the slightly different behavior in the transit compared to a normal exoplanet? And so that is my job specifically within the helping to find aliens. So do people have questions about?
I have a question.
Yeah.
I was wondering, in what way would changes in light be indicative of extraterrestrial technology?
Okay. Yeah. So what we're doing is we're looking for So I guess the thing in general is that we're looking for anything that's weird. And I guess this goes for the whole project in searching for aliens in general, is that we can't really tell if it's aliens or not. But what we're doing is we're looking for things that so far we don't think are natural. So we don't understand the behavior of. And then we investigate it further and further to see, well, is it some other natural phenomenon or is it some non-natural phenomenon? And after further and further investigations, if we can eliminate that it's a natural phenomenon at all, then it probably is aliens.
Okay, cool.
I have a question, Josh.
Yeah.
So you create these light curves that simulate an alien megastructure, and then you feed them back in to see if the algorithm detects them. Do I have that right?
Yes.
Are you that far yet? Have you submitted any, and has it detected them or not?
I have not, so far I have not put them back, so we don't know if they'll find them. But I've created them, but I haven't put them back into the data set.
You know what this reminds me of? I was just reading an article maybe in the last 3 or 4 days about airport security. And I kind of had always known that there was a branch of the government whose job it was to put guns and explosive and things in carry-on and checked baggage to test to see if the scanners are doing their job. And I read an article about that. I think it was the New York Times the last few days. And the scanners only get, no, it was in a Malcolm Gladwell book. That's what it was. I was reading a Malcolm Gladwell book called Talking to Strangers. Great book, by the way. And it turns out that the Transportation Safety Administration only catches 5% of the fake guns and fake weapons and explosives. That it's the same agency, I think, has a subgroup of people to see how well their scanning is doing. That's really what you're doing here, right? Is you're trying to trick the system to make the system better.
Yeah.
I think that's so cool.
Yeah, and what makes it even harder is that we don't really know what we're looking for, because I mean, we have a sample in terms of like what intelligent life looks like, we have a sample size of 1. And in terms of like megastructures, we have a sample size of 0 because we haven't built any megastructures. So like, yeah, could be looking, we're trying to find something and we don't know what we're looking for.
Sure. Well, good luck.
Yeah.
Anyone else have any questions for Josh?
What I do, or SETI in general, or the Breakthrough Listen project.
How did you get involved with the program? Like, where'd you find it and who'd you talk to?
Yeah, so Berkeley has this program called URAP, the Undergraduate Research Apprentice Program, where it would pair, basically mentors put out projects and then you would apply to these different projects to get hired as an intern. So I got into this project through that, but I know that the Berkeley SETI Research Center also offers a REU summer internship for students all across the country to apply to, where you can get involved in that. So the people I worked with, about half were from Berkeley, and the Berkeley people in this project tend to be more on the computer science side, and actually the people who were more on the astronomy side of this project were from all over the country. So there was like one from University of Wisconsin, one from somewhere in West Virginia, and then one from the University of Alabama. So there's students from all over the country can participate in this through the summer REU program.
That is so cool. So those of you who are seniors, if you're interested, you could talk to Josh about whatever college you're going to of doing a project like this. And also the college that you attend may have something similar to Berkeley's URAP. Now, Josh, it's really, I want to point out to the others, that's incredibly impressive that just as a freshman, at a college as great as Berkeley that you already have a research project. That's really, really great. Do you think you're going to keep doing this project for your undergraduate years, or at least another year, or what?
Well, I'm continuing over the summer. I think I hope to continue work in the fall. And then after that, I'm not sure whether I'm going to continue with this or find a different project. But
Yeah, there's value in mixing it up and doing other things as well. You've been doing this a few months, right?
Yeah, I started in, I think, late February, early March.
So you're going to do it at least a year. And
Yeah.
then something else. And do you find it hard being a full-time student and having an internship? Two-part question. And is it a paid internship? Do they give you any money, or is it completely volunteer?
So through URAP, it is not paid, and then they're going to pay me over the summer, and then after that, they may continue to pay me. I'm not sure.
Yeah, that's pretty typical that you start doing an internship for no pay.
Yeah.
And if you demonstrate that you're worth it, particularly after you've done it for a while, and summertime comes along, they know that almost everybody needs summer money in the summer. So for the other students, know that you'll probably have to do a internship without pay for a while, but usually, particularly if you're good, they'll turn into, it's not high pay, but it might be more attractive than flipping burgers for your summer job or whatever.
And then in terms of workload, well, for the semester, Berkeley will offer you units. I think one unit every 3 hours you work, 3 or 4 hours you work. And so you can use that to take less classes and still meet the minimum if you think that classes are a lot of work. But I managed, well, including the units I was given for this internship, I was still under the maximum that they allow. So for me, it was manageable. But because they give you the option of units, you can use that to offset so that you may only typically you have to take 3 classes, but you could do like 2 in an internship.
Cool. Any other questions from any other students? I have a few more, but I want to give students a shot.
How has COVID made your work different than it would normally be? Like, how is what you do now different than what they normally do?
I'm not really sure. I'm not sure if it's different at all, because I guess I don't have in-person meetings, but I guess I don't know how different that is. The mentors that I work with actually they're not even at Berkeley, so I don't even know if we would meet in person anyways. And like I said, we work with the TESS data set, and TESS is currently flying around space. So there isn't much of a lab I can visit to do data stuff. So I don't think there is much difference with COVID.
So Josh, is it hard to extract the data from the data set? What are the steps that you need to follow in order to get a light curve from the data set?
There's been, I can't remember, I think one of the NASA centers has done the processing from TESS for us. So we have this big like data storage data center where we get files which have the flux data, like flux and time data among other data, which then basically is the light curve. So it's not very hard.
Oh, okay. So they sort of pre-digested it for you. So.
Yeah. Yeah, because they're already taking it from, because I think TESS returns images, so they already do the extraction from images to flux data.
Since that question was from Ken, your mentor 2 summers ago at Pine Mountain Observatory, did the work you did with Ken at Pine Mountain Observatory provide any good background for this project? Did it help you at all?
Yes, I think especially the exoplanet transit that we did helped me a lot especially with the background of doing more transit stuff, which is mainly the stuff we're focusing on, and just having the general knowledge of like light curves and flux and like, yeah, but especially the transit stuff that helped a lot.
And for the rest of you students, Ken, if you missed this last week, Ken he lives 20 or 25 minutes south of our neighborhood, and he has a home observatory, and he is a great person to work with, and he's willing to work with one of you or a very small group, maybe 2 or 3, this summer on doing any number of projects, but perhaps exoplanet transits, perhaps cluster activities where you measure the age of clusters or the distance to clusters, or spectroscopy or anything. If you have any questions, well, Josh and Emma have both worked with Ken, now would be a good time to ask about that. Or if you have questions you don't want to ask him right now, you should just email me and I'll connect you up with Ken.
Yeah, I'm more than happy to host anyone who's interested in doing taking some data and, finding some cool stuff about, clusters or transits or any of that stuff. It's a lot of fun. We'll use Excel to extract data. I know a lot of folks don't know how to use Excel, but that's pretty useful to know. And anyway, yeah, don't be bashful.
All right, any other questions for Josh or for Ken or for anybody? Anyone out there? That's pretty cool stuff. I love teaching you all for honorable reasons, but I will admit that one of my more selfish reasons for teaching you is so that I get to brag about knowing you later and learn from you. So now I can brag to my friends in the neighborhood that one of my former students is working for the SETI Institute looking for aliens. That's pretty sweet. For Ken, do you remember Theodora, who went to Pine Mountain Observatory about 8 years ago?
Oh, you bet.
She, everyone else should find this interesting and a good model. Theodora did not end up finishing in astrophysics. She decided that she wanted to work in medicine. And she is going to go to grad school, but she's between undergrad and grad school. She has a job. She's interested in women's reproductive health, particularly in the developing world. It's a great thing to do. But her parents, of course, still live in Portland. And she's been stuck in New York City for most of the pandemic. And she's back in town for 2 or 3 weeks. And, students, take note. Take note. Now, Theodora is 24 years old, maybe. And she's out of college and she's making money. She and her boyfriend and her parents took my wife and I out for dinner when they were back in town. And then this was last Sunday night and it was clear. And so I got to take them out on a star party, which was very fun. Yes, indeed. You know my old saying, if you're once my student, you're always my student. I get to brag about you, and almost all of you will end up making more money than me. I think like 98% of my students end up more financially successful. Don't get me wrong, I love my job. But once you're out of college, a really good thing to do is to take your old man teacher and his wife out for dinner and go stargazing or whatever. So Theodora's doing well, although not an astrophysicist, doing great work, and has a boyfriend. Any other questions from the group? All right, well, here's what I'd like to do. Josh, you want to stop sharing?
Yep.
Ken, you can stay for this if you wish. I will tell you, though, Ken, I'm hoping we'll get a student who wants to work with you, but I definitely have some ideas of things I want to do with you. So I'll talk to you later a little bit. My summer's still a little bit up in the air. But I think what we're going to talk about now is what to do for our very last meeting 2 weeks from now.
So Joe, I'm going to go ahead and take off then. I wanted to hear Josh's talk.
Yeah.
So good luck, everybody, with your finals and stuff coming up. And we'll see you all later.
So great to have you here, Ken.
Great to be here.
So now that Ken's not there, of course, Emma and Josh can tell you about what a great guy he is. He was one of the chief architects on the original Intel Pentium chip. That guy helped change history, working at Intel, designing microchips. He's been retired about 15 or 18 years. He's actually quite a bit older than he looks. He's in exceptionally good physical and mental shape. And all of our mentors who work with me are all super interesting people. All right, so our final meeting 2 weeks from today. Here's what I'm going to suggest. Brennan's got Jeopardy ready to go. If anybody else wants to put together anything fun, do so. And I'm thinking that 4 o'clock, you know, I teach till 3:45. I'd like to make it a virtual pizza party. So what I'm going to do is I'm going to order myself a pizza from Pizzicato down in Hillsdale. And right now, I don't expect you to buy me food because you're teenagers. But once you're out of college, you're going to come back and take me to dinner, right? Okay, once you hit the big time. But I will tell you the following. We do have a little bit of a budget for this club. And what I'm going to do 2 weeks from today at 2 o'clock in the afternoon or something, I'm going to order pizza to be picked up at 4 o'clock at the Hillsdale Pizzicato. Y'all know where that is. And I'll probably order, well, so what I want you to do is if it works for you, and then I'll pick up the pizza and I'll wait outside so that we're all outside. I don't think they let you into Pizzicato anyway. And you can swing by and grab a couple of slices, okay? Free of charge. I'm going to use our astronomy club budget. That's what I would do if we were meeting in person. I would buy pizza. And then let's start our meeting on that day at 4:15. That way people have time. So if those of you who are at school who are going home, just meet me at Pizzicato. And anyone who lives nearby who can come up to Pizzicato, I'll get you pizza. But I'll send out a reminder a day or two ahead of time. And you do have to put in your order. You do have to put in your order. And you're responsible for your own drinks and dessert or whatever. And then we can have at 4:15, 2 weeks from tonight, a pizza party and play Brennan's Jeopardy game. And I'm working on some, and I'll say this, and there will be some surprise announcements, or at least one surprise announcement of a little project I'm working on that I'm not ready to tell anyone. Sound good? All right. If anybody is interested in working with Ken this summer on the projects he described, or with Rob Brown on spectroscopy, or with Margaret McCrae on learning how to find deep sky objects in her old school way, or with Mike McKeag, who showed up 2 weeks ago on doing some astro imaging, or your own project, let me know. And no commitment required. We can just talk about it. Other than that, I'm going to say goodbye and see you around.
Thank you.
Thank you.
Thanks, everybody.
Thanks for
Thank you.
See you later.
Thank you.
I
Hi,
just wanted
Evan.
to ask if there's anything I should do to get more involved with this club if it's ending so soon.
Well, yeah, I have exactly what you should do, because your mom told me that you're going to join me out in Joseph and Enterprise this summer and help me with some star parties.
Yeah.
So what we've been doing is having how to learn to use a telescope sessions for just a very small group of people. And the reason it's a small group and I don't advertise it widely is because it's Rob Brown and I don't know if you know Rob Brown, but he's a man my age who's a Ida B. Wells dad and an expert telescope builder and observer. Way better than me. Way better than me. He's a great guy. We've been meeting usually only about 4 or an absolute maximum of 6 students at a time on short notice in Gabriel Park. Short notice because we have to wait till it's clear, and either Rob or I have to be available. So we've usually been giving people as little as 6 hours notice, maybe 2 days because of the weather. And what would be great is if you wanted to, I'll put you on that list. And that way you can come and you can learn to use a telescope.
Okay.
And you can bring Ian too, or you can bring your mom or whoever, or your dad. Don't bring all of them though, because it's a small group, but you can bring one person. And what I'll do is I'll find a telescope for you to borrow, unless your family already has one. Do you?
No.
I'll find a telescope for you to borrow.
Okay.
And even ideally, if you have room in your vehicle, to bring with you when you go out to the Wallowas. And you don't need to become an expert before you go out there, but you need to learn the basics. And then when we're out in Wallowa County, if you're able to bring a telescope that I loan you, then when we're out there, you won't have to share. Because I have 2 telescopes already out there, and I'm going to take 1 more. And then my buddy who lives out there has a couple of telescopes. But the more telescopes we have, the better. And then what we're going to do is we're going to do some star parties just for my students and former students who are going out there from Portland, 5 or 6 people. But then the highlight is we put on star parties for visitors, both people, families, oftentimes with small children who are visiting the state park, and local people who live out there. That sound good?
Yeah.
So what I'm going to do right now is I'm going to forward you the email list that I have, where I sort of introduced all of this. And it'll be an old email, it'll be a little bit dated, but from now on, you'll be on the list. And then when Rob or I have a star party, you'll know about it, okay?
Okay.
I want to warn you, we probably won't have a star party for the next 2 weeks because the moon is approaching full. Generally, you have star parties half of the time, and that's when the moon is 3/4 full to not full at all, a new moon to 1/4 full, and we're in the other half of that right now.
Okay.
Super. Talk to you later.
Okay. Bye.